Hello, my name is Sean Young. I've started a project called Solang, which is to compile Solidity. Okay, so what do we have for Solidity today? So the Solidity Compiler is a very large C++ project that has, it only can compile to EVM. It's very tightly bound to ETH. It has a handwritten parser and handwritten. It has a handwritten lexer, handwritten parser, then produces UL, and then from UL it has its own optimization parsers, and then produces the final output. So it's an entire compiler written from scratch. It hasn't reused any existing components whatsoever, and also the Solidity language has various limitations, so you can't do string compare, for example. If you Google Solidity string compare, you see some very odd things people will have to do in order to make that work. String concatenation doesn't work, and the maps, you can't iterate them. You need to know the entry, otherwise you won't be able to access anything in an iteration. So with Solang, what I decided to do was start a new code base and write it in Rust, generate the parser from larpop, and use LLVM for optimizations and code gen. So with Rust, that's already a big save because the AST fits really nicely into a Rust enum. So that makes it very easy to work with. Having generated parser also saves an enormous amount of code. And then lastly, using LLVM saves even more code because much of the hard work of a compiler is the back end and the compiler parsers, and I don't have to write any of those. So it targets Substrate. At the moment, it has an ETH and a scale ABI encoder. It's still very much early days, but this is what works today. You can run Solang. You can pass in an -O for optimization. The aggressive is literally the LLVM optimization level, and the Solidity there will compile to a Wasm file and an ABI file. You can just deploy those in Polkadot directly, and it works. The flip of the Wasm is at the moment about 1,500 bytes, so it is smaller than the output of ink. Okay, so as I said, Solang is a new project. It has limited language support. So bools work, uints, ints, sort of a basic arithmetic, have structures and functions, loops and if statements and whiles and so on work, and you can access contract storage, but that's really it. So what I'll be working on now is more language support, expanding language support, and that's supported through a Web3 Foundation grant. I'll be adding more data types first, and adding structs, arrays, mappings, abstract contract storage, abstract contracts, etc. So I'll be working towards compatibility with Solidity. There are some things which won't be able to do because, for example, in Solidity you can write assembly statements which include literal EVM instructions, which won't be supported on Wasm, of course. There is actually an EVM backend for LLVM in progress. That's still early days, so it might be possible to do EVM generation one day. So that's sort of the first aim is to have feature parity, language-wise. But beyond that, there are some interesting things we can do with a new compiler. But the first thing is that having the same ABI encoder decoder as Ink would mean that Ink contracts can directly call Solidity contracts and vice versa. This means, in order for this to work, both Solang and Ink will need to be able to read an ABI file and from that, generate the correct invocations to external contracts. It would be nice if Solang itself can make compile to Wasm, because that would mean that you could have like a playground. In the Polkadot UI, you could have just a free-form text field where you can write Solidity, compile it in your browser, upload it, and use it. Another feature would be very good would be to have arithmetic overflow. LLVM provides all the infrastructure for that anyway. It just needs to be wired up, really, for all the arithmetic instructions. String processing could be so much better. So a simple string compare would be fairly easy to implement. String formatting, just a printf would be good. Other sort of features would be great would be to be able to iterate over mappings, other sort of data structures like dictionaries. So it doesn't have any form of generics. That is, it can be quite awkward. So I imagine something like the type-seq generics would be a good thing to implement. Lastly, it would be nice if you could link C code against Solidity. So what you could do is write some C code, compile it with -f freestanding with Clang into Wasm, and then in Solang you could link that easily by using the LTO linker in LLVM. The LLVM has a linker as a library, so this would be actually fairly straightforward to implement. The difficulty would be to define a foreign function interface for any sort of external programs. Right. Otherwise, so Solang, obviously the first target is Substrate, but once you have language support, adding other targets is relatively easy. So it already supports Subledger Burrow. I've spoken to the guys from Sawtooth and Fabric. They are very interested. So that could be added. Lastly, eWasm is an obvious target to add, which would be very interesting because then you could do you'll kind of compete against Solidity Compiler on its own sort of home ground. But yeah, that's just an idea, really. Right, so a little bit about the source tree. I've divided up into a parse directory. So the parsing stage is very straightforward. There's a LARP Solidity grammar, and that outputs the abstract syntax tree. So there's really just a grammar in there. That's all there is. So in source resolve, that's where all the hard work is. I have to resolve all the variables and generate the control flow graph. The control flow graph is not LLVM specific, but it's obviously tailored to make it easy to generate LLVM IR from that. Then in source emit, we take the control flow graph and we generate LLVM IR. So there's some busy work around generating phi nodes to make that work, but otherwise it's a fairly one-to-one mapping from the control flow graph. And there's the ABI encoder decoder. Then the final stage is the link stage. At the moment, it's just easier to convert a Wasm object file into a final contract Wasm, but that has to be replaced with the LLVM LTO linker if we are to link in other code. And then we have source ABI, where we generate the ABI file. And that's it. I should have included a link to the project, but I only just thought about it about 30 seconds ago. But it's a Hyperledger Labs Solang. That's it. Thank you.